All right, today we're going to start learning trigonometry. So trigonometry is the study of triangles. More specifically, it's the study of how the sides of a triangle compare to the angles of a triangle. So if I had a triangle and I was looking at this angle and I made that angle bigger, so if I spread that angle out, you'll notice that this side of the triangle is going to get longer. And if I make that angle shorter, smaller, then that opposite side is going to get smaller. So there are some very definite relationships between the sides of a triangle and the angles of a triangle. Okay. The trigonometry that we're going to study always deals with right triangles. And that's sort of the simplest version of trigonometry. There are formulas that deal with any triangle, and no matter what its angles are, they are more complicated than what you're going to see this year, and you'll run into some of those in secondary 3. So I want you to pay attention here and notice that the biggest side is the hypotenuse, and the biggest side is opposite the biggest angle, which should make sense conceptually. The larger an angle, the longer the side that angle opens toward. And it's also true that the middle side is opposite the middle-sized angle, and the small side is opposite the small angle. That is a fact with every single triangle. The size of the angle has an effect on the size of the opposite side. So when we're dealing with right triangles, we have a hypotenuse, and then the other two sides are called legs. So this is a leg, and that's a leg. And then those legs lie opposite of these angles that we call base angles. So every right triangle has a right angle and then two base angles. Okay. When we deal in right triangle trigonometry, we're going to focus in on one of the two base angles. And sometimes the problem will tell you which angle to use, and sometimes it won't. But technically, you could use either angle. So I'm going to select this angle here. And that angle is going to have a name. It's usually a letter. Often in trigonometry, we call that angle theta. Theta is just a Greek letter, like pi, alpha, beta, gamma, delta, epsilon, zeta, eta, theta. And this is lowercase theta. It's like a 0 with, I don't know, wearing a belt. And if I call that angle theta, then we name the two legs according to how they are situated with relationship to angle theta. So notice one of the legs touches theta and one of the legs doesn't touch theta. So we name the leg that touches theta after the geometric word of next to. And the geometric word for next to is adjacent. And then the side that doesn't touch theta, the leg that doesn't touch theta, is referred to as the opposite. And then the hypotenuse is the hypotenuse every single time. So when you're dealing with in trigonometry with right triangles, you need to identify which side is adjacent and which side is opposite, and then of course what side is the hypotenuse, and that totally depends on which base angle you choose. So if I were to move theta to the other side, how does that change the naming of this triangle? Well, the hypotenuse didn't move. It's still in the same place, but the opposite and the adjacent are going to switch sides. Okay? So, let's draw a triangle. And let's do a 3, 4, 5 triangle. And let's call this X, and let's call this Y. Okay? Oh, actually, I'm getting a little bit ahead of myself. So, if I'm looking at angle X, what is the name of this leg? Is it adjacent or opposite? Well, adjacent means next to. So if I'm looking at x, angle x, this is the adjacent and this is the opposite. And then, of course, this is the hypotenuse. So the way we're going to connect angles and sides is we are going to divide the lengths of two of the sides with reference to that particular angle. And there are 6 ways to do this. I could divide the O by the A, or I could divide the A by the O, or the O by the H. And with 3 sides, there are 6 ways to perform that division. Each one of those divisions has a name, and the names are totally weird. So the first name is the sine. And I honestly don't know where these names came from. Sine. S-I-N-E. And we abbreviate sine as S-I-N. Don't call it sin. It is the sine. That's just its abbreviation. And we say that the sine of theta is, and this is just going to be a ratio of 2 of the sides. So the sine of theta is the O side divided by the H side. And then the next ratio is called cosine, and we abbreviate the cosine, C-O-S. Don't say cos or cos. The cosine of theta is simply the A side divided by the H side. Okay, and that'll make a little bit more sense here in a minute. The third ratio is called the tangent. And the tangent is abbreviated T-A-N, and that is the name of the ratio where you take the O side and divide the A side. Okay? So, if I had, let's get rid of that, and these. So X, what is, let's go back to our 3, 4, 5 triangle. What is the tangent of Y? So we are focused in on Y. This is the H side. What is the name of this side with reference to Y? It's adjacent. So this is the adjacent side, and this is the opposite side. So the tangent of Y is the O side divided by the A side. So that's going to be 3 over 4. And that's how trigonometry works. Now, it does get a lot more complicated, but that is basically what we're going to do today. Oh, that's always H. We'll just leave that. Okay. What is the cosine of X? So we focus in on angle X, and then we look at our definition. The cosine of X is going to be the A side divided by the H side. So what will that be? What is the A side with relationship to X? So if I put my theta here, which number is adjacent? Which means next to? 3. So it would be 3 over 5. Like that. Okay? What is the sine of angle Y? So the sine of Y is going to be the O side divided by the H side. So if I look at Y, which side is O? 3 over 5. Now, you're going to have to memorize those. But never fear, we have an easy way to do it. We use the mnemonic SOHCAHTOA. So what this means is sine is O over H, cosine is A over H, tangent is O over A. And when I was your age, some math teacher taught me this. I don't even remember, some story about an Indian chief named SOHCAHTOA. It didn't make any sense. And then somebody taught me a way to remember this, which is totally not school appropriate. But once I teach it to you, you'll never forget it. You ready? SOHCAHTOA. Some old hippie caught another hippie tripping on acid. Yeah, not school appropriate. Some old hippie caught another hippie tripping on acid. Can you remember that? Okay. There are 3 other ratios, and you're going to need to know them a little bit. For the most part, we're going to stick with sine, cosine, and tangent, but each one of these has an opposite, sort of. The opposite of sine is called the, oh, oops, got that wrong. It's called the cosecant. And we abbreviate cosecant as CSC, and it's just the reciprocal of the sine, h over o. And then the cosine is opposite what we call the secant, and the secant is abbreviated, wow, that was new. The secant of theta is defined as the inverse of the cosine. And then the last one is called the cotangent. And it's just the reciprocal of the tangent. So the cotangent is A over O. Okay. The way I remember that is for each one of these, so this has a co and that one does not. This has a co and that one does not. This has a co and that one does not. So sine is the reciprocal of cosecant, and cosine is the reciprocal of secant, and so on. Okay, so let's change this a little. So we draw a new triangle, 5, 12, and 13. Let's call this A, and let's call this B. What is the cosine of B? So we're focused in on angle B, and cosine is A over H. Which side is going to be A? 12, and H is 13. So that is 12 over 13. Okay, what is the secant of A? So secant is the upside down version of the cosine. So we're focused in on angle A, and I need to do H over A, so that would be 13 over 5. You see how that works? Okay. Sometimes instead of side lengths, they're going to give you angle, or they're going to give you variables. So let's call this A and this B. We get X, Y, and Z. What is the tangent of angle A? So we focus in on A, and tangent is O divided by A. So if we look at angle A, the O side is going to be Y, and the A side is going to be X, Y over X. Does that make sense? Do you need to see another one of those? Okay. What if we have this? 8, 10, and unknown, and I want the cosine of A. Well, in order to figure that out, I need to know the adjacent. Cosine is adjacent divided by hypotenuse, but I don't know the adjacent side. So I need to use the Pythagorean theorem to figure that out. So x squared plus 8 squared equals 10 squared. So x squared plus 64 equals 100. Subtract 64. and I get x squared equals 36. So x is, take the square root, x is 6. So the cosine of A is going to be 6 over 10, which simplifies to be 3/5. Does that make sense? Okay. Let's get rid of this. All right, what if I have, let's say 6, let's say 6 and 7. And this is A, and this is B. What is the sine of A? What is the sine of A? So, we need to figure out how big this is. So 6 squared plus x squared equals 7 squared. 36 plus x squared equals 49. And then subtract 36. And I get x squared equals 13. And then we take the square root. So this is the square root of 13. Okay? Well, the sine of A is going to be the O side divided by the H side. So that is root 13 over 7. Okay? Now you do have to be a little bit careful. What if I wanted the cotangent of A? What is the cotangent of A going to equal? Well, that would be the A side, which is 6, divided by the O side, which is root 13. And I'm not allowed to leave the square root in the bottom. So I need to times this by root 13 over root 13. And the top becomes 6 root 13. And the bottom just becomes 13. Okay? The only other problem you're going to run into is it might ask you, what is the sine of 10 degrees? So what that means is, if you have a triangle with a 10-degree angle, so say this is angle A, then what is the opposite side divided by the hypotenuse? And the neat thing about that is, the answer is the same regardless of how big the triangle is. So if I have a little tiny triangle and I'm looking at a 10-degree angle, and you have a really big right triangle and you're looking at a 10-degree angle, my O divided by my H is going to be the exact same value as your O divided by H. We'll get different fractions, but your fraction will simplify to be my fraction. Which means we don't even need the triangle to figure out what that is. All we have to do is open up our calculators and push the sine of 10 degrees. Was I doing sine? Yeah. So if I type in the sine of 10 degrees, I'm going to get 0.17. And that's true on small triangles, on medium-sized triangles, and on large triangles. So in the problems on your assignment today, if it asks you what is the sine of 10, then you just have to plug it in. Now, there are two ways to measure angles. So your calculator will either say GED or DEG for degrees, or RAD for radians. And this will only work in degrees. So if your calculator is giving you numbers that are wrong, they're not technically wrong, you're just using the wrong way of measuring angles. Okay, your assignment is called 4.3 worksheet. It's in Alex. Get to work.